Thank you for the very kind introduction. Before I continue, I'd like to acknowledge that this is not only my work, but rather it's a collaboration between multiple international scientists, and they're not listed as co-authors of this talk. So what are the challenges of phasing out uses of hazardous substances? Well, because of the large number of hazardous substances and their broad range of uses, it's impractical to ban all uses of hazardous substances in one step. Some uses may be essential because they serve a critical role for which alternatives currently do not exist. On the other hand, some uses may be non-essential and can be eliminated without first having to find functional alternatives. And some uses may be essential but entirely substitutable by non-hazardous substances that provide an adequate functionality. So we decided to examine more closely one of the famous success stories of chemical phase-outs, that is the Montreal Protocol on substances that deplete the ozone layer. And it was, in fact, this international agreement that first introduced the concept of essential uses or essentiality. So we've applied the approach to PFAS, which are per and polyfluoroalkyl substances, but it could be applied to other hazardous substances, for example, or even, for example, microplastics. So to critically evaluate the idea that hazardous substances are essential in modern society, the essentiality of their usage should be carefully tested against the available evidence. So before proceeding in this task, a definition of essentiality is needed. And there we attempt to refine the criteria of the Montreal Protocol. And we published a paper on this application of essentiality to PFAS, where you can read more of the details, as shown on the bottom here. We came up with 3 categories for defining if a use is essential in our paper last year. So category 1, or non-essential uses, are those uses that are not essential for health or safety or the functioning of society. Examples we gave in the paper were PFAS uses in, for example, ski waxes, in dental floss, and in repellent surface shorts. And category 2 or substitutable uses are those uses that have to be regarded as essential because they have important functions, but where alternatives exist, thus making their uses no longer essential. So they're substitutable. Examples are the use of PFAS in firefighting foams and in certain water-resistant textiles. And then category 3 or essential uses are those uses that are considered essential by society because they are necessary for health and safety or other important purposes for which alternatives are not yet established. Now, even if your use should fall into category 3, they should not be considered permanent. Innovation in the development of non-fluorinated alternatives can lead to it moving up to a higher category, category 2. So now I'm going to just walk through the concept and show how it can be applied to PFAS in food packaging. So, but first of all, you need to understand the common features of PFAS that make them so useful. So the main features of perfluoroalkyl moieties, which are in all PFAS, are as follows. First, they have a high chemical stability due to the strength of the carbon-fluorine bond, which is often called the strongest bond in organic chemistry. So fully or perfluorinated carbon chains have even shorter and stronger carbon-fluorine bonds. So perfluoroalkyl chains are also simultaneously hydrophobic, which is water-hating, and also oleophobic or oil-hating. And this ability to repel liquids of a wide range of polarities is perhaps a unique property of this chemistry, which is hard to replace. So PFAS are especially useful as fluorosurfactants, where they can lower the surface tension of water down to 16 millinewtons per meter, which is about half that compared to hydrocarbon surfactants. And they've been used in paints and inks and firefighting foams and many other applications, but they're also very useful in surface protection. So they have very low surface energies compared to hydrocarbon or silicone-based polymers, and they provide this simultaneous water and oil repellency. So they've been very useful in food packaging to provide oil repellency in, for example, microwave popcorn bags, fast food packaging, baking papers, etc., etc. So which PFAS are used in food packaging? Well, historically, it was precursors to these very hazardous PFAS, so-called PFOS and PFOA, that were used in food packaging. And they had both surfactant-based and polymeric chemistries that were used. And it was hypothesized that the reason that everyone in the industrial world has microgram per liter levels of these compounds, PFAS and PFOA, in their blood, because of the widespread use of these long chain fluorinated chemistries in food packaging prior to the major manufacturers phase out, like 3M, in between 2000 and 2002. And there's evidence in the literature for this. For example, this paper here in Environmental Health Perspectives down at the bottom. But nowadays, the fluorinated chemistries used, these shorter chain C6 or fluorotelomere-based polymeric products, and also poly and perfluorate ethers. And the old long chain chemistries have been phased out in the last 20 years as a result of either voluntary initiatives by industry, but also through regulatory pressure. As mentioned on the last slide, PFAS provide very good water and grease and oil repellency. They also provide breathability, which is another important function for food preservation. So the fluorochemical manufacturers will say that the modern fluorinated products are safe, but they're still concerned that they can enter food and be a potential risk. It should also be noted that some packaging products need repellency to oil for weeks to months, for example, butter wrappers, where others require oil repellency only for a few minutes, like fast food wrappers. This means there are different performance requirements depending on the precise application. So what are the alternatives to PFAS? One is to introduce a physical barrier, for example, plastic or aluminium coating on the paper. The downside is the paper may be less easy to recycle and it may not be breathable. Another option is to come up with an alternative chemical barrier. And some options are natural grease-proof or vegetable parchment. And these contain dense cellulose structures. And there are other chemical alternatives which are also used in outdoor equipment, which utilize silicone or hydrocarbon-based polymeric chemistries, but these formulations do not tend to be very good, very oil repellent, so that's a downside. And then there's also nice to mention this POP3 project, which is a project which is being coordinated by RISE in Sweden. And in this project, multiple companies have the aim of phasing out PFAS from multiple uses. And there are some paper companies in this project as well, and they're developing novel chemical barrier solutions for food packaging materials. So there's a novel chemistry that's been developed by BIM Chemie, and it's being tested by providers of food packaging materials, two other companies that, and they've made a kind of grease-proof paper with this novel chemistry, and it's promising, but it requires further optimization. But they have some technical issues with the paper getting stuck in the machines and things because it's thicker than the old paper. But I don't think these are insurmountable challenges. And I think, this is a substitutable use of PFAS. So are PFAS essential in food packaging? Well, I think historically there were many non-essential uses of PFAS in food packaging. For example, before the phase out, I've heard from the fluorochemical industry, they were widely used in things like candy wrappers. So they were much more widely used than they are now. Today, the short chain chemistries are used, and I believe many of these uses are non-essential or substitutable. Some people from the paper industry have told me that PFAS is still needed in some applications where the longer oil repellency is needed. But I think innovation is ongoing, and I think these uses should be substitutable. So I would conclude that PFAS can be phased out of food packaging materials, and Denmark's already decided to do that this year in 2020. So I think PFAS are under global pressure, that systemic change is underway. So I think there's belief, there's optimism for PFAS to be phased out from a whole range of different uses. And if we look at some of the drivers for this, you can see actually industry are driving this. There's actually a push from a lot of chemical industry and producers who want to remove PFAS from their products. So they're innovating along the value chain to ensure that. So phasing out PFAS and other hazardous chemicals is not necessarily anti-business. It's actually good business for a lot of companies. And then we have the pull from the NGOs, the consumers and authorities, which is also driving out the phase out. But there are other parts of industry that obviously are not for this phase out and are pushing back against the phase out of PFAS. So in particular, the fluorochemical industry, who may understandably want to protect their chemical products. So the conclusions, the way forward, in my opinion, the essential use concept can guide the phase out of hazardous substances. I believe it makes sense to focus on these category 1 or non-essential uses first, the kind of low-hanging fruit for phase out. The category 2 are a little bit more challenging, substitutable uses, because you want to avoid regrettable solutions. And this whole science of chemical alternatives assessment has evolved in recent years. So you've probably heard of things like design for the environment, green screen, cradle to cradle, but there are many other approaches of chemical alternative assessment evolving. And finally, may need a little bit more innovation for some of these very where you need very durable use, oil repellency in some applications. But I think these challenges are not insurmountable, as I said earlier. So finally, thank you for your attention. I include a few acknowledgements, which I don't need to read out here, and I look very much to the discussion of the essential use concept.